Go. Everybody say hi, India and Ellie.
Oh.
Hi, India and Ellie.
Okay, they don't like you. Okay, so trig functions. This is just an elaboration on what we've been doing already, except they will do something like this to you. They will give you a point, like let's say the point, I'm going to give you the point 3, 4, okay? And what you're going to do is you're going to plot that point on a coordinate plane. So take a look at this over here. This is my coordinate plane, okay? And if we plot the point 3, 4, 1, 2, 3, 1, 2, 3, 4, whatever, I'm going to put that dot up here in the first quadrant, okay? And what we do is we make a triangle out of that dot. We connect him back to the origin first thing, okay? That makes like my hypotenuse side of the triangle. But then we always connect that dot back to the x-axis to make a right triangle, okay? Do you see how they did that here? Okay? And then what we're going to do is we're going to label the sides, okay? So since we went 3 units in the x direction, this bottom side is 3. Do you see that? We went 4 units in the y direction, so this side on the right is 4. And then the hypotenuse, we used the Pythagorean theorem to find. Now, I picked really nice numbers, 3, 4.
5.
Tegan, you just learned that today or talked about that today. 5 has to be the hypotenuse, right? Okay? And that means that I can look at this angle theta right here, and I can find the sine, cosine, and tangent of that guy, okay? So sine opposite over hypotenuse. If we're doing sine of that angle theta, what's the opposite hypotenuse? What will sine of theta be?
Opposite's 4.
Hypotenuse is
Hypotenuse is 5.
5. There you go. Sine of theta is 4/5. Okay? Same thing with cosine, adjacent over hypotenuse. So we do cosine of theta, and that is equal to
3 over 5.
3 over 5, right? Okay? Now, we could do tangent as well and cosecant and all those guys doing the opposite adjacent, that type of thing, okay? But down here, they're just talking about how you find the hypotenuse. Okay, so take a look at this. This is the formula that they say for finding the hypotenuse. The hypotenuse they have labeled as r, okay? So they say the hypotenuse is r, okay? And the way that they get this formula is, basically, we did the Pythagorean theorem, right? We called r our c squared, right? And we said c squared is equal to a squared plus b squared. That's how we would find that 5 right here by doing the Pythagorean theorem, right? But if I want to just find c, don't you take the square root of that? Right? So it would be the square root of a squared plus b squared. That's why they give that formula to you like that, okay? So they're just writing it out and saying you use the Pythagorean theorem to find that other side, okay? Now, one more thing that I want to show you, put it down over here in this corner, before we do this next example, and I want to show you this, okay? My dot that I had in the first quadrant there, we always connect it back to the x-axis, or back to the origin, right? Yeah. And then we always make bow ties and not hourglasses, okay? Bow ties, no hourglasses. And what I mean by that is if I have it in the first quadrant, I'm going to connect him back this direction, right? If he was in the second quadrant, here's my line, I would connect him back this direction, right? If he's in the third quadrant, I draw my line and I connect him back this direction to make my triangle. You see what I'm doing? The fourth quadrant, if I have a dot here, I would connect him back this direction. We're making a bow tie, okay? What we don't want to do is, there's my line, I don't want to make an hourglass, right? I don't want to connect him back to the y-axis, right? I don't connect him back this way. These are illegal things to do. We're not making hourglasses. We want to make bow ties, right? This is good. We don't do this. This process is bad. Bow ties, not hourglasses. Do you see what I'm saying? Mm-hmm. When you're given a dot, you connect it back to the origin first, but then you connect it back to the x-axis to make to make a bow tie, not an hourglass. Yes?
If I go fast, can I go to the back?
Yes. Okay?
Yes.
So, bow ties, no hourglasses. Okay? Let's go down to this example. Example 1. They want us to find sine, cosine, and tangent of this angle. So they're saying plot the point -3 and -2. They've done that for me over here. -3 and -2 is this dot. Okay? Connect him back and make him into an angle. And then we make a bow tie. Are you boys back there listening?
Wait,
Yep.
can you go up
Okay, we're making him a bow tie.
a little more? There.
Are we good?
Yeah.
Okay. All right, making bow ties. Okay, so now we have to label our sides. All right, what's this top side of this triangle going to be? This guy right here. -3. We've gone -3 in that direction, right? This side right here is labeled as -2, right? Because we've gone down 2. -3, -2. Yeah?
Yeah.
Now we need to find the hypotenuse side. Okay? And this one's not a nice one. Doesn't come out nicely. So we do have to do the Pythagorean theorem. So we do -2 squared plus -3 squared equals c squared. Okay? What's -2 squared? 4. Is it positive 4 or -4?
Positive.
Always positive. Always positive. Plus 9 equals c squared. 13 equals c squared. So my hypotenuse is the square root of 13, and you are going to leave it as the square root of 13 and not the decimal number. Yes?
Yes.
Do not. Okay, now, your hypotenuse, by default, will never be negative. Ever. Ever, ever. Because when you square it, it will never be negative, right? So the square root of 13 is that guy. And now we have to find sine, cosine, and tangent. Okay? So we're doing sine, cosine, and tangent. Now, we need to know what angle we're dealing with. So of this triangle, which angle are we dealing with? Where's theta even live? Always the angle by the origin. So everything that's attached to the origin, that's where your angle will live. Yes? That's the always angle theta that you're looking at. Okay? So if I go up to your bow ties and hourglasses, angle theta will always live here, or here, or here, or here, depending on where your dot is. It's always the one that's attached to the origin. Yeah?
Okay.
Okay? That's where your angle theta is. So now we just have to look at this diagram and we have to find sine. Sine is OH, opposite hypotenuse. So, looking at angle theta, what's the opposite? -2. And the hypotenuse is the square root of 13.
Can't have that.
We can't have a square root in the bottom. So, we have to
It's gonna be negative.
rationalize. Multiply by the square root of 13 over the square root of 13. So the top is,
-2 square root of 13 over 13.
yep, and square root of 13 times the square root of 13 is just 13. That's how you rationalize it, right? Some of you guys can do that in your head, right? It's just the bottom number, the bottom radical moves up to the top, and then you unsquare it, right? That's what he looks like. So that's the sine value. Okay, cosine is AH, adjacent over hypotenuse. What's the adjacent side?
-3.
-3 over
Square root of 13.
the square root of 13. But we rationalize that, and it becomes
3 square roots of 13 over 13.
-3 square roots of 13 over 13. Yeah? Can you do that in your head yet? If you
Yeah.
can't, write it out. If you can't, write it out. Okay? Tangent is opposite
-2
adjacent.
over -3.
Opposite, adjacent, and there's one more thing I can do to that. -2 over -3.
2 over 3.
The negatives will cancel, so it's positive 2/3. Yeah? Okay? And that is sine, cosine, and tangent of that angle, given those coordinate points. Okay? Happy with that?
Yeah.
Yeah?
You gotta stop. We have 5 minutes.
Okay. I'm trying to think. Yeah, let's go ahead and stop there. Okay? All right, I am going to give you your homework assignment, and I want you to do the first 4 on it. The first 4 on your homework assignment, which is exactly like this one. Okay? Do the first 4 for homework.